Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Well, Houston, we've had a problem. Today we want to learn about the concept of pH and POH. Now, likely you've heard the idea of a pH, pH balanced, all these different things out in the media. You've heard about that. Well, pH has to do with the acidity of substance. Now, the pH is a scale, it's a number, and here's a diagram of it. pH that goes from 0 to 14, where 0 are the most acidic things, 14 are the most basic things, and 7 is something that's neutral. 14? Why do we make it a 10-point scale? This doesn't make sense. Well, it does. Because when we measure things, remember what makes an acid is what? H. H positive. What makes a base is OH negative. Hydroxide, hydrogen ion. Do you see H, OH, acid, base? This testy little P. What's up with the little p? Well, it turns out the p is a logarithmic mathematical thing. So you know what pH is? pH is equal to the negative log of the concentration, remember brackets means concentration, of the hydrogen ion. And there's something called POH, and I'll bet you can figure this out. POH equals the negative log of the concentration of the hydroxide ion. So if you take the negative log of something, of the hydrogen concentration, then you know what it is. And it turns out there's a relationship between pH and pOH. There's a bunch of mathematical equations. I'm going to use them here in this video. Is we can take the pH and we add it to the pOH, and it always adds up to a funny number 14. That's where the 14 comes from in the 0 to 14 scale. And we can also say that the concentration of the hydrogen times the concentration of the hydroxide is equal to the number 1 times 10 to the minus 14th. Ah, there that is. All right, this has to do with something called the equilibrium constant. We'll learn about that in a subsequent video. And we can also kind of go the reverse. So I'm going to kind of rewrite this equation, but the opposite way. If I go 10 to the power of the negative pH, that's equal to the concentration of the hydrogen. And if I take 10 to the power of the negative pOH, that's equal to the concentration of the hydroxide. Now these are the pH, pOH equations that we're going to now use. So this is a moment for Houston, we've had a problem, to get your calculator out. What I want you to do is I want you to copy down this table. We're now going to use this and our calculator to see if we can solve these problems. So if I know the pH is 3.2, what I'm going to do is I'm going to come over here. If I know the pH is 3.2, this equation is going to make it super easy for me to do this, right? So let's go to the calculator here. I can simply take 14, 3.2 plus something equals 14. So I just take 14 minus 3.2, and voila, I get 10.8. That's just using this equation here. Now these, they're not so hard. If I have the pH and I want to get to the hydrogen concentration, I can use this equation as 10 to the negative pH. So I can say 10 to the caret power, right on this calculator, so that's the caret button is right here, right? To the power of the negative pH, which is negative 3.2, and I get 6.3, that was this one, 6.3 times 10 to the minus 4th. And then I can take, actually let's figure a different way to do this. I can actually take 10 to the power of the negative POH, so let's just do that. Well, next one we'll do something different. 10 to the power of the negative 10.8, and the hydroxide concentration is 1.6 times 10 to the minus 11th. Let me say a couple note here. If you look at these two, they need to multiply to 1 times 10 to the minus 14th. And even though we could do that on our calculator, let's sort of do it in our head. 11 and 4, or negative 11 and negative 4, is negative 15. And if you take 6.3 times 1.6, that's going to come out to 10. 10 times 10 to the minus 15th is the same as 1 times 10 to the minus 14th. Always has to work. We could have solved that the other way. Let's jump down and do, if you will, number 3. If I've got the hydrogen concentration, so this one, I'm going to do negative log of the hydrogen concentration. So I'm going to say negative log, right? The log button is right here, times, and I'm going to type in the number, which was 2.3. Remember, second function e, right, on this calculator, negative 6. And then I get 5.64 right here. So this is 5.64. Makes sense? And then I can just, to get this number, I can take 14 minus this. So take 14 minus, I'm just going to do second answer on my calculator, and that's 8.36. Now let me show you how I can calculate this number. I can just take 10 to the power of negative 8.36. I go 10 to the negative 8.36 power. Or, watch what I do here. If I take this divided by this, that gives me this. So I can take 1 e negative 14 divided by 2.3 e negative 6. And that gives me 4.3 times 10 to the minus 9th. Again, 9 and 6, 15. 4 times 2, 8, but the 3's make it 10. You see how this is all working out? Let's jump up to this one right here. If I do 4.5, I'm going to say 10 to the power of negative 4.5. Now that's going to give me, that's a POH, that's going to give me the hydroxide concentration, 3.16 times 10 to the minus 5. All right, and then I can take 1 e negative 14 divided by, all right, if I could do this right, 1 e negative 14 divided by 3.16 second e negative 5, and that's going to give me the hydrogen concentration, 3.16 times 10 to the minus 10. That's kind of interesting. It's 3.16, but 3 times 3 is like roughly 10, so that's not bad, right? That makes sense. And now, watch what I do here. I'm just going to say log of the second answer. So I want to take the negative log of this. And I just said log, but I got negative 9.4. But you know what I'm going to do? I can take the negative sign off and realize that's 9.4. And let's do this one here, last one. If I start with this one, watch what I do. I'll just say the log. I know this is, I'm not saying the negative log. You may want to do that. 9.2 second e negative 3. And that gives me negative 2.04. So that's the POH. So it's 2.04. But now on the calculators, you can see it says negative. But if I just add 14, that's like taking 14 minus 2.04. And that gives me 11.96. And now I'm going to do 10 to the power of negative 11.96. Gives me the hydrogen concentration, which is 1.1 times 10 to the minus 12. Let me say one more thing about significant digits when we talk about pHs and POHs. This number right here you would think has two significant digits, but in reality it only has one, because the first number in the pH or the POH actually denotes like the power, right? And so this one only has one significant digit. So probably should have said 2, so we could keep 2 digits or something like that. That would have made a lot more sense. So 3.20, because here I have, this is 2 significant digits, this is 2 significant digits. So significant digits and pH can be a little bit confusing. So pH and POH. Now the big concept, right, we said at the beginning, is that P means negative log. That's basically what P means. And H represents the concentration of the hydrogen. And if I'm asking the question, which is actually the more important question, which of these solutions is acidic, which one is basic, which one is neutral, all right, all I ever do is look at the pH, right? If it's less than 7, it's an acid. If it's more than 7, it's a base. So what we've got here, 3.2, that makes this an acid. More, this is 9.4 is a base because it's higher than 7. This is an acid, and this is a base. So you might be asked a question like that. Very simple. It's mathematics. You can do this. Use your calculator, because Houston, we've had a problem.